Hi. More than 2,000 years ago, Euclid organized geometry around a small collection of starting assumptions called postulates. Most of these seemed simple. A straight line can be drawn between any 2 points. We can draw a circle with any center and any radius. But one assumption was different. Eventually, we named it the parallel postulate. In short, it says that if you have a line and a point outside that line, exactly one line can pass through the point without ever intersecting the original line. Now, unlike Euclid's other assumptions, this one seemed complicated. It did not feel as obvious or even fundamental. So, mathematicians wondered whether it was really necessary. Perhaps the parallel postulate was not an assumption at all. Perhaps we could prove it from the other postulates. So, for roughly 2,000 years, mathematicians tried. Again and again, they constructed proofs. Again and again, their reasoning failed. Now, by the usual definition, they failed. But then, something remarkable happened. Mathematicians began asking a different question. What if the parallel postulate could not be proven because it was truly independent of the others? And what if they replaced it with something else? Suppose there were no parallel lines through the point. Or suppose there were many. Now, at first, these possibilities seemed absurd. Surely, changing the parallel postulate would produce a geometry filled with contradictions. But it did not. Instead, mathematicians discovered entirely new geometries. For example, on a curved surface, the angles of a triangle do not necessarily sum to 180 degrees. Parallel lines may behave very differently from what we learned in school. The geometry of a flat surface is only one geometry among several possibilities. Eventually, these new ways of thinking gave Albert Einstein the mathematical language he needed to describe curved space and the theory of relativity. Wow. So what's the big idea here? 2,000 years of unsuccessful proofs opened the door to a larger understanding of reality. Those mathematicians did not solve the problem that they originally wanted to solve, but they discovered that their question was pointing towards something far greater. And I find that encouraging because many of my small ideas or small problems often are part of something bigger than I ever imagined, if I'm open to see it. Many of my failures and struggles were not dead ends, but they were invitations to question the path itself and to discover an entirely new world of possibilities. So, how about you? What problem are you trying to solve that you are ready to quit? Is the problem important? And if it is likely worth persisting.